Good day and welcome to the final webinar in this gauntlet series on GreyNoise tags. I'll be saying this again later, but if you have specific questions on how we use AI at GreyNoise, you've actually picked a really great day to attend a webinar at GreyNoise, because I believe between Daniel and myself, we can probably answer any of those questions that you have as long as we have enough time. Today's installment is designed to show you how GreyNoise is leveraging what I guess we would call practical AI, so like not the foofy lying stuff that a lot of vendors do. We actually use it, techniques to eventually get to a state where no interaction with our sensor network will be unexplained. It's a really lofty goal, but I'm pretty sure we can get there. And I got to figure out how to use my computer now. Give me a second. There we go. So as we've noted in previous sessions, our GreyNoise sensor network processes millions of interactions every day across nearly every known network protocol. Now we have over 1,100 tags that help classify IP addresses making these interactions. At any given moment, around 60 to 65% of these IP addresses are tagged with unknown intent, right? And around 35% are tagged as malicious, leaving a tiny fraction classified as benign. Now, there's a sizable chunk of these millions of interactions that we just store, and we do store. Amazon loves us because we store a lot of data, and leave that for later processing because we just can't identify what's being poked and prodded at this moment in time from the attackers or other folks that are out there. And the perils in this vast uncharted territory can feel a bit like some of the original world marine navigation maps, right? There's some marked or known territories and paths, but a vast area of unknown that could hold anything. So we have this policy at GreyNoise that the humans in our employ operate at human speed. Sure, there's the occasional need for crunch time, but we expect our team members to embrace a healthy work-life balance, and that includes avoiding abnormal stress at work. And I mention that because this is a vast amount of data that our humans have to go through. So while our detection engineers are quite literally some of, if not the best in the industry, we only have so many of them. And I just checked this morning, cloning is still illegal. So that means that there's a very finite amount of traffic that an individual human can explore on their own without some aid. Now, just like the characters in the SRU, oh wait, you probably don't know that. You probably know like Marvel MCU or DCU. This is the Schoolhouse Rock universe. They needed a place to go to get adverbs at scale. We needed to build our own factory to help analyze these incoming packets at scale, to make it easier for our humans to identify truly taggable traffic. But okay, what does that mean or actually look like? And that's kind of the whole point of today's webinar. So imagine that this is all the non-tagged web traffic that GreyNoise sees in 10 minutes. It's just packet after packet after packet after packet after packet. And as a human, you would need to go through every single packet by hand or try some naive sorting mechanism to figure out what's new, novel, bad. Neither approach is great, and it will absolutely mean missing quite a bit of traffic, and that just multiplies over time. So just imagine that. So for now, our Sifty's AI processing factory, we limit our scope to the most researched and attacked protocol, HTTP. We pass in all these HTTP packets to Sift, and now we have to process them. To do this, we wrote our own custom HTTP large language model, or LLM. Yes, this is similar to what you know of in ChatGPT land, except ours is focused solely on what might be seen in HTTP packets. This involves cleaning up the parts of the HTTP messages. I might just say web from now on because it's really hard saying HTTP over and over again, that don't matter from a data science perspective, breaking these messages up into tokens, and then creating numeric vectors from all this so that we can do fun maths on them. Now, you can hit up this URL for more information on how we approach these protocol level embeddings. And when you go there, there's plenty of other links that have content that some of them deep dives on this process, and you can explore those. There's tons of URLs there. We just don't have enough time today to go into the weeds like that. We may be able to in some of the Q&A part, but we just don't for the core part of the webinar. Now, for this Sift work, we also maintain a historical index of HTTP traffic seen in the last 30 days, and we can tweak that to be like more or less in terms of the number of days. And we can compare each process packet against this corpus of data. So that is, we can query the database and compare the numeric vectors to see if any of new samples that we've seen is close to a historical sample. The approach used is called approximate nearest neighbors and involves using fancy algorithms to determine which HTTP packets are closest to other web packets. And if we were to plot these numeric vectors and segment out the groupings, it might look something like this. It might actually be a lot harder to discern. You might have to do it in 3D space to really kind of see it. That's why we don't plot them. We just actually use maths on them and use fancy algorithms. Now, once we've identified target packets in recently captured interactions, we group similar ones together so they can be reviewed as a bundle. We then perform additional filtering against historical baselines to find new and interesting clusters. And that means that our detection engineers, who would have had to naively look at 2 to 3 million packets each day, now only have to work through 10 to 100-ish packet groups to determine if there's any novel traffic that needs tagging. And to put it another way, I just had to use this graphic from Daniel's previous webinar because our design team just is amazing. Our SIFT process bionically enhances our team members to help them focus on just what matters out of all this traffic and interactions that we have. So let's go back to that 10-minute example that we talked about a few minutes ago. So, and just to refresh your memory, each one of these dots is an HTTP packet that came in within the last, say, 10 minutes. And then imagine again that you have to look at the characteristics of each one and figure out a way to keep track of what you've seen, group them together manually, and realize that you just can't do it. Our Sift factory can process these packets incredibly fast, and this enables us to quickly identify and group novel payload clusters that our talented humans can then investigate. And from here, this is sort of a made-up example, but this is kind of how it actually works, and it can pull things that you would not be able to do at human speed in any way, shape, or form. So this is all theoretical. We're still talking at a pretty high level. Let's get practical, and what does this actually look like in real life? What do our detection engineers do every day as they dig into the output of our Sift factory? For those that attended the previous webinar, you got a tiny glimpse of this as like Ron Bose worked through some of his workload that he did to identify some F5 tags, and also gave you a peek at some of the what he does on a regular basis to kind of go through and do this. We're going to walk through it a little more slowly here and give you some views into each one of the processes that we have. So what you're seeing here is a view of our internal version of Sift. So if you want to play along at home, you can hit that URL. It's sift.labs.greynoise.io. You do need an account to do that. And that's the public view of Sift that you'll see. It's virtually the exact same thing that you're seeing here, except for a couple of things. First, we throw a 7-day lag there, so we get to see 0 days before you do, and you can't. And so bad guys can't actually use the 0 days against other people. We also have a ton of integrations for our ticketing system, better access to internal databases, and a whole bunch of other things like that. So you just can't have access to that. But apart from that, the reports are pretty much the same. So we're going to dig into some of the components of a typical SIFT report. And I picked this one kind of at random. It had the characteristics that I wanted to talk about. So you could go through any one of them and just kind of lather, rinse, repeat from what you're going to learn about individual sections. So as we group these payloads together, we have our AI-based system take on the persona of an expert threat hunter or an expert detection engineer, maybe a combination of the two. We ask it to review the packets that we've identified in those clusters from that process we just talked about and describe them in detail to take even more load off of our team. We eventually want to make it so our team can process these things incredibly quickly and get onto other more complex tasks that they want to do and perform within the organization. So in this example, the AI has looked at all the payloads that we're going to see in a minute and determined that they represent a possible shell shock attack. That's how it created that title. It further estimated the potential threat level, 1 through 10. And also, I was shocked when we first asked it to do this, but because I figured it's an LLM, it's going to say I'm perfect, I'm confident all the time. It does a pretty good job of saying how confident it is that in the actual assessment that it did. It's probably still made up to a large degree, but it's nice to know that it doesn't think it's perfect all the time. And as you can see, it also comes up with some high-level determination of the type of attack. This is all there so that our humans can look at things very quickly and know they can either move on to something else or they should dig into something a little bit more. Now, in this particular case, we don't have any existing tags for any of the payloads that you're about to see. And in other circumstances, we might have tagged some, but not all of the payloads. And in those cases, we can use the grouped packets to enhance our existing tags. So make our tags better than they have been before. And that's great because that helps us identify what usually ends up being malicious activity. Most of these things that we find are malicious. Not all, but most is malicious. So these are the payloads that I was talking about. There's just 3 on here in this group of 132. Now, we're only showing 3 because when we tried to show all of them, the browser crashed. and we're not like, we got to get work done, so we basically limited it to there. You, our team, and anyone that uses the public Sift has access to all the payloads, but this gives enough of a hint to help start a tag if we need to dig into a tag and to give an idea what's actually happening on here. And I've noticed that our detection engineers can spot patterns a little bit better sometimes at this level than computers can. That's why we have humans, because we're still smarter for now than all the AI systems out there. And if we scroll down a bit onto the page, we decided that we also wanted to help our detection engineers out a little bit more and have the LLM take advantage of the 30 years of free content that all of us security folks have given to the world, and have had the world has then processed all these big billionaire companies. And it came up with a pretty good spot on description most of the time. Like, and I'll ask Daniel about that a little bit later, but I've not noticed where it's been egregiously wrong about any example that is provided. And then to help it cut to the chase even further so that some of our folks can even do further at a glance processing, we have it come up with some keywords at the bottom too. And we are doing suricata tagging. I think we've mentioned that a couple times in the webinars already at GreyNoise. And a suricata tag and making one is a lot like creating an English sentence. So we actually asked the LLM to take a stab at creating a pretty naive rule, and we will never use these rules outright, at least right now. But it can help shave off some precious minutes later on if we do determine that the cluster is a new tag or we need to enhance a tag. And we have a lot of data at GreyNoise, so we layer in some additional telemetry data the old school, boring way, right? They're just databases, left joins, just so we can provide context for folks about the IP addresses, what they're doing that may help inform other things they want to do when creating a tag. It also helps them see what these IP addresses were doing, because they're usually doing other really bad things when they're doing stuff against what we're seeing in the set we have not tagged. And just for kicks, because this work, even with Sift, can be pretty tedious. We periodically ask the AI to come up with a snarky remark about the payloads. It's not always a gem, but it's come up with some pretty funny ones that have actually made me lol out. So it's nice to have a little bit of a fun part of the job. And Ghosty likes to tell jokes, and it doesn't always tell great jokes. So our Sift factory already helps us quite a bit, but there is a ton more that we can do. So what does the future of tagging look like at GreyNoise? So to find out, I've asked Daniel Grant, the brilliant mind behind Sift, to join me today to have a chat about where we might be heading. And everyone, as we said before, please feel encouraged to toss in questions for Daniel as well, and we'll get to those at the end. So first of all, Daniel, just one more time, thanks for joining me today. I appreciate taking time out of your day to do this.
No, this is great. Thanks for having me on.
Awesome. So right now, Sift works with, as I've said about a billion times during this webcast, it works with just HTTP data. Is there plans to expand beyond that?
Yeah, definitely. We want to investigate other protocols to add capabilities, but HTTP was like an obvious first choice. It has a very language-like syntax, so the LLMs really work well with it. It's largely made up of like English words or
Gotcha.
English partial words and tokens like that. And a lot of our detections are based on HTTP too, so it's a huge chunk of the space. Really good place to take the first bite. But we do want to look at other protocols like SSH Telnet and other application-specific stuff. But our first priority is really to get this HTTP version up and running really well so you can get some use out of it. And we've sort of like exited the R&D MVP phase of things, and we're really like pushing this as a product for the company. So we're gonna get it all shiny and accessible and multi-tenant and all that fun stuff. And then we can start layering on extra protocols.
Cool. And that'll be really cool to see when we actually get that out to everybody, like beyond just this little trial that we've done. So as we expand beyond HTTP, though, like as you mentioned, like HTTP is nice. It fits into sort of a language. It's got sort of words and that you would be able to do normally for sentence embeddings, like has been done in a lot of other cases. What are some of the challenges when like we work with pure binary protocols? Because that's a lot of what we see in some of the like industrial control and other spaces out there.
Yeah, binary is very different, but we do see a lot of it, and we do want to have it as sort of like a catch-all if we don't have any other way to process something. Like the first major step for working with any of these is to sort of create a feature vector out of the traffic that you see. So
Okay.
using an LLM for HTTP traffic makes a ton of sense. We can do a lot of cleaning and pre-processing, and the tokenization of the HTTP words, like paths and variables and all that stuff, all work as expected. Like that was like a nice pairing. But binary is very, very different. It's really hard to like chunk that up into words. So LLMs probably aren't going to require the same aren't going to like be the correct approach for that.
Gotcha.
So we're going to require some different techniques that are a bit more abstract and assume a lot less of the data. So there are some things like LSH, locality sensitive hashing,
Okay.
n-gram analysis, maybe even algorithms similar to like compression algorithms could be used to sort of fit this arbitrary binary payload into a fixed feature vector space. So we can have like a catch-all for that.
Ah, so, like, using some of the gzip techniques that were kind of popular or that became famous sort of in, like, the October, November timeframe last year.
Yeah, yeah, something like that could be really useful because what is GZIP doing but sort of like making a record of patterns and then sort of counting those patterns and like placing them in the right location and all that sort of stuff. Additionally, like that's the first part of like featureizing, and then maybe we can find what things are sort of interesting. But doing the analysis that we're doing with Sift is a lot different too. Using a commercial LLM on a binary protocol, that's going to be very, very much hit or miss. They're going to have like the LLM is going to have to try to figure out what's going on, and that might not even be
Right.
possible. But so we'll have to develop some new or perhaps old techniques to handle some of that. I've got a long history in doing machine learning based malware detection, which is taking a binary file and running it through a model to figure out what you can about it. So we might be like falling back on some of those old school approaches that are used in sort of machine learning based AVs to say like these are things we can tell you about this binary string without actually knowing what that binary string is.
Gotcha, gotcha. So one thing that the team has been super impressed with, and all of us have really, is it's really smart. As we saw, like it identified shell shock from just patterns that were inside the HTTP payloads. The analysis, like I mentioned before, like generally pretty spot on. Like they're not flawless, but they're also not wacky. Like it's not like some of the random hallucinations that other people would get if they were doing things and just work with plain old chat GPT. But what are some ways that you're thinking about to maybe make SIFT smarter, like provide even more context? Like, are there things out there that we aren't doing right now that you'd like to dig into to make the reports better, help humans out better? Like, basically, is there a way to make SIFT even smarter than it currently is right now?
Yeah, yeah. I mean, we're constantly working on stuff like that. And I sort of put it into two buckets. One's to add context, add features to the sort of reports and the analysis that we do. And then the second is to make those individual components of the analysis better
Okay,
over time. And so there's some interesting things we can do. Some of those are like big stuff. Some of it's like little life improvements. One, we just added sort of the MITRE attack matrix information, so that
that's
tactics and
right.
techniques. So you might see that pop up soon. We're also trying to introduce filtering in so when you see this whole report of 50 items, there might be some like PHP unit that you don't really care about, or maybe you're just really tired of seeing like log4j's like JNTI strings. I know I am. So you want to disregard those. So we want to introduce some filtering that's as a capability there. So that makes it more useful. That adds more features, but making it smarter is like slightly different. Anyone that's played with some of these commercial LLMs like GPT-4, Claude, Bard, Llama, all that sort of stuff, you generally don't control the model and can't
That's a
improve
good
it.
point.
If you do, it like costs way too much money and it's not really worth it. But you can improve how you interact with it. And so that's one of the big things. You can improve the questions that you're asking, how you're giving examples to it, all that sort of like prompt engineering stuff. And then very important that a lot of people don't really think about as much is you can do like fact checking on the back side. So you get like after you get your response to check to see if that's worthwhile or if you need to just
Gotcha.
reanalyze something. So checking that structure and the information is really key to make a project that's like useful and dependable and not just like gimmicky. So that's
Neat.
that's the thing that we're really focusing on is like making sure that our information's right and not just there.
That's that's cool. I know the team appreciates every little enhancement that you add into there because it does help us get to tagging faster or understanding what's more important than anything out there. So it's great that you're thinking about that. Now this year we've introduced a new sensor architecture that will let anyone run one or more sensors using GreyNoise tech. If folks don't know about that, please dig into our website. It's out there. It's in I call it beta. There's some other cooler term for it that I don't know, and I'm going to get yelled at for that, but that's fine. So folks can run this year, anyone community or customer is gonna be able to run one or more sensors of their own. So basically it's their data. Is Sift gonna be able to work on that? Like, will they be able to use Sift? Is it useful for them to use Sift?
Yeah, yeah, they will. And this is like a really sort of exciting thing because previously this is that we're looking at just like the global scale of all of GreyNoise's sensors, collecting data, and we're just telling you this is what new is happening on the internet. But to be able to tailor that to like, this is new, what's happening on your network is like a really cool twist that we can do with
Gotcha.
that. So like, yeah, GreyNoise has a lot of like sensor personas that we're doing with this new architecture. So if you want to like run a box that looks like something specific, we can do something like that. So, and we're constantly collecting data on them, and we're running a lot of these sensors
That's
ourselves. So
true.
we like this background data that we're always collecting.
That's
So,
great.
so when people are running their own sensors on the traffic hitting their network, that's cool and all. And like right now, like in the sort of beta program and all that sort of stuff, you can collect the PCAPs and you get that information. But unless like your idea of fun is like scrolling through PCAPs on a Friday night, it needs a little bit more of a boost to be like really useful. And so that's where like Sift can come in and actually help out. So we'd actually take that network traffic data from the GreyNoise sensors that you'd be hosting, compare it to the historical traffic data from your own sensors and from GreyNoise's network, and then pluck out the interesting bits that look like they're just either targeting you or new to
Cool.
you or something like that, and then do a whole SIFT processing on like the analysis on it. So it would be like a custom tailored made SIFT report for your network. So that seems like a pretty cool thing, at least to me.
Yeah, that
Big
is
things
super
happen
cool.
in the next quarter or two.
Yeah, that is super cool. I'm looking forward to I'm actually looking forward to Sift doing that processing so that I mean I am one of those folks that will gladly scroll through a bunch of PCAPs on a Friday night because I'm old and have nothing better to do. Also, surprisingly though, a number of other gray noise humans also scroll through PCAPs on their free time in their because of the sensors they've deployed. So like maybe there's more of us out there than we think. I think I have time for one more question before getting to everyone else's questions. So right now, as I mentioned, like the Suricata rules are kind of naive. They're not even close to production quality. Do you think it's going to be possible to get Sift to create better Suricata rules out of the gate, or is that something that is just not achievable?
No, I think very much we can do that. So our
Okay,
Suricata and like the SQL rules tool are 100% right now LLM generated, and they're always just meant to be a jumping off point. Like
right.
I would never encourage anybody just to copy and paste and run because that's a bad
I
idea.
mean, if you like alerts, it's great. I mean,
Yeah. And so we've heard that feedback and we knew it all along. There's going to be a lot of false positives, false negatives, all that sort of stuff. And we're working on a new approach. That's very much in early R&D, where we're going to try to sort of procedurally generate the rules, not using an
gotcha.
LLM, but using the samples that we found through Sift that we want to match. So like the items in the cluster that we've just identified, and then comparing that against samples that we don't want it to match, like a representative group from our corpus. So this is very similar to how you would like train a machine learning model. You have
Got it.
like
Gotcha.
the things that you mark as one, things you mark as zero, and then you let the machine do it. But we're doing this to try to generate text that would be workable in a Suricata rule. So we think this is going to work out way better. It's still very experimental, but it could very well lead to something like automatic tagging, where a rule is generated and you can click to deploy, and it might actually be useful and not too noisy.
Yeah, that'd be great because it'll give the team time to dig into like vulnerability research, right, and proof of concept development and things like that, versus actually have to sit there and scroll through things. That's awesome.
Yeah,
Daniel, thanks for taking the time. Can you hang for a bit to maybe answer some questions that maybe the folks that are viewing have?
for sure, for sure.
Awesome. So that's it for this final session, apart from the questions. We do hope this series of webinars has demystified the tagging process at GreyNoise and also provided some detection engineering avenues for you to explore on your own. Please do not hesitate to reach out to the labs team if you have any questions ever on detection engineering, data science, et cetera, at GreyNoise. And thanks for coming on this journey with us. And I'm going to go reach out back to Ashley, who I usually call
Yes.
the Overwatch on our podcast, and see if we have any questions that folks have submitted.
Yeah, we've had a bunch come in. So just a reminder, you can put them in the chat or into the Q&A. All right, we'll get through as many as we can. First one says, how does the version of HTTP affect this analysis? HTTP 2 is quite a bit different than HTTP 1. God, that is hard to say.
Yeah, it is.
Yeah, so we're pretty like all encompassing, and the models that we're using can handle like both really, because you can train things on like multiple sets of data, and it can sort of separate them out itself. So it works for both pretty well.
Right. Bob, anything you wanted to add to
Yeah,
that?
that's great. Yeah, I would have said the same thing.
Great. How does HTTP chunking affect this analysis?
That's interesting. I mean, like, and I'll let Daniel answer that, but for the most part, we are working on an entire packet that comes in right now. So like until we have more higher interaction honeypots with a new sensor network, that's not a thing we have to deal with at this moment. But I'll let Daniel add to that because I do know there's some ways that we can deal with that as we process the entire stream of information coming in.
Yeah, well, from this side of our stack, from like the data collection side, we haven't really had to deal with that much at all because we'll just get the sort of request, string, verb, and string, and then all the HTTP headers, and then the payload associated, and that's all that we care about. So once we have that, we're off to the races. And sometimes if things are chunked up, we can deal with them just as chunks, and you might just have clusters of the specific chunk that works out. So yeah, it hasn't really been a problem for us.
All right. Next question. Most binary protocols are two-way, so you won't see an exploit until 2 to 3 round trips where you have to respond to the messages correctly. How do you plan to handle that?
Yeah, that's a very good question. And some of that is with the new honeypots that we're standing up, the new personas. We're collecting like the session traffic. So hopefully we'll be able to collect the right part of that interaction and work through that. So maybe the first bit of the interaction, like we're not catching any flags on that one, but the later bits where there's actually something malicious happening, we would catch. But this is still a lot to be researched and determined. So very early stages on that.
Great. All right, so we have another one. Are you decoding, and I don't know if this is called quick or just QUIC payloads?
In the new honeypot sensor network, we do have a quick persona, and we are able to process those payloads as we would with normal HTTP payloads.
Great. How do you expect or hope for users to use Sift?
I think generally speaking, we have a specific use case that we developed it for internally, which was to help our detection engineers, narrow down the focus of what they need to look at every day and be able to create tags better. And we've seen like tremendous help there. I think we were like 2 to 3 times the amount of tags per week that we were previously developing. I think this would be very interesting for SOC analysts when they're looking through, like, you get the report and you start drinking your morning coffee and you see like, was there anything weird that hit our network yesterday? Is this something that like might be interesting to look into more? Or like, are we actually seeing like traffic of this vuln that just got released that everybody in the media or on Twitter is like saying like, patch your systems, go look out for this. Is that a real thing, or is that just, hype? So using it as a way to sort of gauge your actual risk and figure out like how what's actually happening on your network without having to look through like so many different alerts and vendors and look through raw packets and all that sort of stuff.
Right. Let's see, we just had another one. Is there a prioritization of volume of something untagged versus a novel new payload?
The way that we prioritize things in Sift right now is through the threat score that is generated. So the things that look like they are the most threaty, those are the ones that you see first. But later, as we're working through this stuff, we do want to be able to allow you to sort of like filter, search, sort on your own criteria. So one of the things that some of our researchers do, they look through this and say like everything with a threat score over 9 that doesn't have any tags besides like web crawler, which everything is tagged web crawler. That's the thing that they want to look at because they want to find that new novel thing. So we want you to be able to sort it and search it the way that you want to, but right now it's just sorted by the threat score.
Right. Maybe we need a new character named Thready now.
Oh my, yeah.
Evil.
Wait,
Evil
no,
Thready.
I'm not doing another web. No more webinars. No,